meeting. So thank you, gentlemen. And I'm Anoop Aggarwal, and I lead the Vehicle User Experience Group within Infineon. And today I'm going to take you through Infineon's instrument cluster solutions for sophisticated graphics. So here, our agenda quickly. So I'm just giving an overview about Infineon initially, and an overview also about our automotive MCU offerings. And then we jump into the graphic solutions for instrument cluster, which is today's topic. And therein our key solution in the term of Trevio and its enablement use cases, and not to forget other complementary Infineon products for cluster, because we are a holistic solution provider as a company. And yeah, MCU is just one part of it. So a quick glance. You must be aware Infineon is the largest automotive semiconductor company in the world. And automotive is one of our key segments as it accounts for about 43% of the revenue. And we are a global company. We have more than 46,000 employees across the world, majority of them being also in Asia Pacific. At India itself, we have 3 locations, offices in 3 locations, and more than 1,300 engineers working. We are the #1 in automotive, as well as also in power semiconductors, and very close #3 in the overall MCU market. We did about €8.5 billion worth of revenue in the last financial year. So being the largest automotive company is one thing, but Infineon is also a holistic solution provider, be it a consumer domain about consumer IoT, or also in industrial domain, industrial IoT, drives, smart home, and connectivity domains like 5G. Connectivity also touches base now in Wi-Fi, Bluetooth, and USB domains. So we provide all these solutions with the point of view of sense, compute, and actuate. So wherever there's a sensing domain, we have sensors, then we have microcontrollers for computing, as well as also memories. And then also for actuation, we have power semiconductors. We are #1, as I mentioned. In the connectivity domain, we do address the same with the Wi-Fi, Bluetooth, and USB. So we cover the entire spectrum of requirements for a digital world. And when we talk about automotive, then we do provide scalable platform solutions. And scalable is one thing, but in automotive, you must be aware that quality is the key thing. And we proud ourselves by talking about not just parts per million of failures, but actually parts per billion. So that's the kind of quality that our customers are demanding. And we are not just a good quality silicon provider, but also an auto-qualified software, because our customers want to reduce their risk of implementation, and providing an MCAL software, for example, with safety compliance, enables them to reduce the risk, and reduce their cost for the end user, as well as a better user experience. So while we do that, the solutions are not only for high-end. You will imagine entry and mid-end solutions and silicons are also provided by Infineon. So these are in the entire spectrum of requirements, as I mentioned, sense, compute, connectivity, graphics. And in the automotive domain, the key requirements being automotive, I think you must be aware of Oryx MCU, the TC3X. So this is basically covering the, this slide is just to inform you that all the subsegments within a vehicle, like driver information, body control, chassis and safety, powertrain, ADAS, all these subsegments are addressed with the spectrum of MCUs, which are auto-grade AEC qual MCUs. And a majority of these high-end requirements are addressed with our Oryx TC3X and TC upcoming 4X MCU. These, you must be aware, are AEC Q100 grade 0, that is 150-degree temperature requirement, and as well as also ASIL-D safety requirement. So very high-end processing and safety and security, which is covered through this. On the other hand, when we talk about body and driver, we have a Trevio series. So Trevio 2 is the upcoming MCU, which is launched, and this addresses both body connectivity as well as the cluster requirements. When we talk about clusters, it's not just the instrument cluster, but also an heads-up display. You have also camera inputs coming from, for example, from digital mirrors, and also a use case, for example, LED headlights. This is some unique LED headlight use case, which is also addressable using the Travio. And for all these requirements, there is basically a need to address it through safety now. So ASIL B compliance is required, and maybe not that much on the temperature grade wise. So we do support grade 1, which is 125 degrees C, and which covers the entire spectrum of these requirements. So today our session is on the graphics, and I'll be addressing most of my talk on Travio series, which is our, let's say, the central compute platform for the graphics usage. So what is the requirement here? From a technology perspective, what do we need and what does customer require? They need low power, high efficiency. So body control, especially, and also in clusters, you don't want to dissipate a lot of power when you are in sleep mode. So we do have enablement in terms of hibernate mode, and the power requirement can go as low as 5 microamp, which is the industry's best. Then you need a scalable performance, and this set of MCU goes as high as 1500 DMIPS. And scalability, which we will touch base upon in another slide, how we address various requirements for cluster graphics. And then safety, as I spoke about. Then connectivity. So over-the-air update is a key requirement now, as you might imagine, and FOTA is what is enabled with read while write flash kind of technology, as well as the memory enablement. So Infineon being the largest, one of the key solution provider for memory, we also support with interfaces within the MCU, that is eMMC and quad SPI high speed. In terms of connectivity, also you need Ethernet, CAN-FD, security. We will touch base upon that also. We provide compliance to EVITA full and the complete graphics enablement. So this is the entire, just the key features, what customers are looking at: security, safety, and not just that, also scalability in terms of performance, and also, while we do that, also the low power and also connectivity. So all of these are addressed by Travio. And now touching base on the scalability from the cluster requirements perspective, you can appreciate the fact that we do have solutions starting from low end, and we address them like cluster MCUs. So 2 MB of flash, 4 MB of flash, and going up to 6 MB of flash for a graphics MCU. And within that, we also provide graphics RAM, also called video RAM, so 4 MB, which is very high, and it's not really required if you want to, so you don't need an external memory per se if you want to display something like 720p resolution, dual screen for 720p. You don't even need an external memory, but yes, you can go higher. So this is something you want to remember. This part, the highest grade, will actually support a full HD, that to dual of them up to 12 inches. So this is very nice. And of course, as I mentioned, it's scalable. You can even support one screen. So you go down with, let's say, 2 MB of video RAM and 512K of RAM. And then you go down further, then you may not have the graphics. You just need an LCD and maybe some, analog gauges. So we do support those in entire spectrum of these parts, and then you just have the LCD here, and maybe some displays along with the gauges. So very low end to very high end, and entire requirement very scalable for the customers. On the right hand side, of course, we mentioned about software. I have a different slide on that, so let me jump into this now. A little bit detail about Travio. So this is ARM-based, which is one of the things which customers might want to appreciate. Going up to dual core, 320 megahertz. Both these cores, M7, 320 megahertz, and an additional third core, which is a dedicated core for crypto. So asymmetric and symmetric cryptography, HSM enablement, SHE standards are all supported, and EVITA full. So this core can also be used as a supplementary core, something like a VIP processor. So, a vehicle interface processor, you don't need an external MCU with that if you want to do that. So it's not just used for crypto, it can be used as a general purpose core for additional safety requirements also. 6 MB of flash, we talked about the VRAM, and then various power rails that's supported. And we will discuss about how voltage regulators are built in and how they save the cost. Connectivity interfaces, so you have Ethernet up to 4-channel CAN FD and 12-channel of SCB, that is a serial communication block. Very interesting IP because it flexibly is configured as an SPI or a SCI or I2C. And then there is a unique feature, CXPI, which is also supported, that further lowers down costs for customers. It's an outshoot for LIN, and it reduces the weight of the vehicle by reducing wires, while still increasing the reliability of the communication, going up to 20K watts. So very interesting. And of course, we do support still the LIN. And memory interfaces, of course, since you want graphics and you need external RAM and flash interfaces, not flash interfaces, you may want to have single, dual, quad, and even octa SPI interface, and also hyperbus. So as I mentioned, along with that, we also have stepper motor control with the 0-point detect up to 6 motors. All these parts that I showed in the last screen, and I'm going to show in the next screen also, are supporting this. So along with that, of course, coming to graphics, 2.5D, that's what we call as a graphics engine, enabling the vector drawing and video outs, up to 2 of them. We will discuss about that. And also sound module, supporting the I2S interface to the amplifiers. And then other general peripherals like the PWMs, up to 50 channels of them, and then 48 channels of ADC, 12-bit ADC, SAR ADCs basically. And we also support an RTC, internal and external oscillators for that matter, and some eFuse options. DMAs also, peripheral and memory DMAs are dedicated DMAs. So in all, very high performance delivered, as I mentioned, up to 1500 DMIPS of performance is delivered by this series of MCU. And we discussed about scalability. These are just briefly about the part numbers and how the performance of the MCUs are scalable from right from WQVGA to WVGA, then 720p, and even higher full HD resolutions. So one of these higher end part, I'm not yet allowed to show you, but yes, please contact me or any of our salesperson within Infineon. We will get you more information about the highest end part here. And the one which I showed in the last screen is this part, CYT4DN. And you can easily imagine, the graphics, for example, starting from here, we add the Ethernet, and we also add the simple video out here, and also the core frequency increases from 160 to 320 megahertz. Then it goes up to dual core now, single core with 240 megahertz of M7, with 2.5D of WVGA added, okay, and 1 video out and 1 video in. And then we have now 2 video out and also a JPEG decoder with 2 cores, M7 plus also. In all these parts, you have security built in, which means M0 plus is already there. So all in all, 2 cores here, M4 and M0 plus, to all the way to 3 cores, 2 M7 and 1 M0 plus core. Yeah, and why should customer then choose? What is the other advantage? Of course, we provide the scalability, and I spoke about features, which are within itself a big deal, but also about cost, as our Indian customers are very sensitive. So we do have built-in voltage regulators that can help you save up to $2.5 worth of BOM externally, and then also a VIP processor, as I discussed. And then there is some thermal management inbuilt into the MCU, along with also a boot flash, which you might have to otherwise have externally if you use another SoC, and also some PCB layer kind of optimization. So you save up to $7 worth of BOM. And the other advantage that you might want to have is enablement. So tools, kits, software, you name it, and we have it. So we provide free software in terms of sample driver libraries and MCAL software, which is available at a cost because these are quality compliant and safety compliant. Then also the HSM performance library, a library that is written by our security experts. And this is basically compliant to SPICE and also taking care, and it's a very small footprint, very high performance, exploits the hardware feature that is the HSM block, and some self-test libraries for flash, ROM, RAM, etc. We provide FMEA manuals and also the safety manual to help the customer to make the system safety compliant. And then some software services, custom software services are also provided by Infineon, depending on the need. So you can always contact us if you want something customized in terms of software. We support all famous tool chains You can see those names on the screen. I don't have to name them. The idea to take care of these is to make sure that customers do not feel the heat. They don't have to change the tools for using and migrate while they migrate to Travio. In terms of hardware, small, 144 LQFP hardware to as high as BJ packages, daughter card and motherboard concept is also supported. So you can flexibly remove the daughter card and change it. We also provide a graphics driver, a 2D graphics driver, enabling dual screen display out as well as camera input, and supporting also a warping tool and also some third-party HMI tools. In terms of HMI tools now, we have a separate...
1 more minute, please.
Yeah, sure. Thank you. So HMI tools basically are certified by Infineon, and we basically make sure that our tool vendors, for example, Altia, Crank Software, they all make sure that hardware features are completely exploited. And security, I will not go in detail, but yes, HSM, having HSM and true FOTA features using the dual bank actually enables you to eliminate all the security threats, hacking, and so on. So we do support everything in terms of whatever I discuss, full Avita and so on. One of the use cases is also a safety companion chip. So you can use this chip with a 3D SoC where graphics overlays and CRC checks are performed by this MCU while it displays on the screen. So very good use case. So apart from being a normal companion chip where you can use communication, MCAL, and so on, you can also use that as a safety SoC, safety chip for a 3D SoC. In terms of graphics, just quickly, we can display up to 2 screens of HD resolution, okay, and a wide HD resolution for a single screen, and also a video capture of RGB MIPI CSI2 4 lanes is supported of this resolution that you see on the screen. And please get in touch with us to, if you're looking for higher requirements. But otherwise, our series of MCUs do support 2.5D rendering of the graphics, JPEG decoding, ISO compliance, and alpha blending, scaling, rotation, color graphics, warping on the fly with the external memory. So we do provide SMIF interfaces for external memory that I was discussing about, decompression from external memory on the run, and all these graphics that you might be already aware about. So skipping that and the penultimate slide from my side. So we do provide complementary products also. So it's not just a Travio. Please also look into the complete solution. You don't want to, spend your time in vendor management or quality management. So having Infineon in your portfolio will help you deal with just one person and one company while you gain access to something like an HMI interface using PSOC MCU, CAN FD PHYs, LIN PHYs, and also power supply. So to supply Bluetooth, Wi-Fi, memories, RAMs, you need power supply. So we do have multiple voltage regulators called as OptiReg. And also for Bluetooth Wi-Fi, you can use our AROC family. You can use only Bluetooth and BLE, or a separate chip for Wi-Fi, or a combined module for both of them, all termed as AROC. So please get in touch with us. With our Infineon portfolio, you get access with the entire thing. Just to summarize, instrument cluster is moving towards digital displays and HMI interfaces, and Infineon is a leader in the same domain. And we do provide solutions in the cluster and HUD, right? And other than that, we also provide scalable driver solutions, SBCs, connectivity, and flash, RAM, security offerings. And while we do that, we also provide the premium-centric, customer-centric approach for support in the graphics tools and software area. So I will conclude by saying, sit on the Infineon bandwagon and let's enjoy the journey for clusters together. Thank you.
Thanks so much, Anoop. Truly appreciate. I'll move on quickly to our next presentation. May I now invite Ms. Rashmi Rao. She is the Industry Manager for Automotive at MathWorks. Rashmi, the screen is yours.
Thank you.
Let's keep it to about 15 minutes. Thank you.
I will try and do that. Can you see and hear me all right?
Yes, Rashmi, I can see your screen and we can hear you.
All right. Okay. So when Dipanshu came to us and asked us to speak in this very interesting event, and thank you, Dipanshu, for this opportunity, we were very tempted to look at the software angle of this. So I will be talking about model-based design for the next generation of software-defined mobility. And I agree with Mr. Paul that we can't really separate automotive electronics from software. So let's quickly get into the topic now. So I want you to rewind a few years for those of you who have been in those times when we had the first digital transformation. And the idea really was to use software more and more to enhance the hardware. So the thinking was, how can I add software to basically enhance all the hardware that I have on the vehicle? Now, as we stand today and look at the future trends of electrification, connected and automated driving, we know that this is going to reverse. So the software is definitely going to drive everything on the vehicle. And this bold claim that we are making, which also I think was kind of reiterated in our inaugural session by Mr. Mudlapur and Mr. Paul, is also very sharply discussed in this McKinsey report that came out earlier in this year. And McKinsey actually goes as far to say that will be the primary driver for the future vehicle development. So for us as an industry who have traditionally been mechanical centric, we are slowly moving to develop more software, to think more like, with software centric approaches so that we can deliver the promise of mobility in the future vehicles that are going to come out. So if we agree that the future of mobility is going to be software, what does this mean for engineers like you and I, and for engineering organizations who are building these vehicles? Well, at the simplest level, it heralds change, and some of them are probably going to be disruptive for the industry. So I would like to focus on three themes that we feel will change the software development in the automotive space. The first will be driven by complexity. We heard a lot about this in the earlier sessions as well. So essentially, we will have to reimagine many aspects of how we are developing the vehicle because the complexity of software is going to explode. And it's not just the vehicle build that will change, but it is also how we develop this software that's also going to change. And that's the second theme I have on the slide. How do software development processes change so we can deliver what is expected in the mobility of future? And then Mr. Paul said he doesn't want to address the white elephant. Well, I have tried to do a little bit on those lines. Certainly AI is a big driver with the immense amount of data that we have in our vehicles. And with the advances that we have made in computing, we definitely want to use more and more AI in developing software and electronics of our vehicle. And this will certainly change the way we write requirements, the way we develop software, and the way we offer newer solutions around our business. So with these three themes, let me look under the bonnet of each of these a little bit further. Let's start with the complexity of software. And I won't spend too much time on changing architectures. We already heard a lot about it from our earlier speakers, but essential to say that it's no longer possible to have individual ECUs connected by harnesses, taking care of these functions. We need consolidation, and that's the birth of domain controllers and going forward the zonal controllers. Next is the trend of decoupling hardware and software. And this is also, as we observe, changing the dynamics of how an OEM and a tier one will operate in the future. We see OEMs wanting more control, setting up software factories, and in general, a trend that I want software that can be ported on any hardware. This also gives rise to the trend of the middleware, and we heard about this as well in the earlier presentations. Now, as we all know, software is generally ready before the hardware and before vehicle prototypes. And additionally, today, the engineers have to integrate multi-domain systems coming very often from very diverse teams. Now, think of automated driving, where a perception is probably written by a team who are computer scientists who need to integrate with controls team who are very different in the way they operate and in the way they visualize systems. So engineers going forward will tend to focus more on system integration and also early verification. That will be one of the essential ways for them to deal with the complexity of software. So this was a quick look at complexity of software. And let me take you to the next paradigm, which is how will our processes change? Now, many of you know the good old V cycle that we have followed for many years in the industry have served us quite well thus far. But we also need to understand that the future mobility has a vision of a car, which is a perpetually upgradable machine. So this calls for faster development, faster release cycles, and also the ability to introduce functionality into the field. So the V cycle is slowly giving way to more agile processes. And to deliver on the promise of a perpetual upgradable machine, we are finding more and more it is helpful to adopt the so-called DevOps methodology. So this is a combination of software development, which is the dev part, and the IT operations, which is the ops part. And again, we already heard the third theme, which is about cloud. Corporate initiatives are certainly driving the development workflows to be taken to the cloud and to containers. And this is mainly because engineers then get an access to higher performant hardware, and it enables this enormous collaboration between remote teams that we are seeing more and more in the OEMs and the tier ones of today. So this was a little bit about how the process is going to change. And let's quickly get into the third factor, which is how AI will transform our software. Now, AI is changing the landscape so dramatically that it is often very hard to bucket them. But at a very broad level, I've tried to bucket these under three categories. The first one is engineers want to use data to understand better how their vehicle is used. And based on that, they fine-tune the designs and the requirements of the product, which gives us our first point. How can we mine requirements from the data that is available to us today? The second factor is about how can we use AI to improve product developments that we are already doing today. And this calls out to things like digital twins, IoT, and so on. So how can I deploy AI to do it faster, to do it more accurately, and so on? And the third bucket is quite intuitive. How do we develop newer capabilities that would earlier have not been possible without these AI technologies? So largely, these are the three opportunities that we see with AI transforming software. Now let me shift gears to the next part of the presentation. I spoke a little bit about what our view is on how software is going to change, let's say the way we build, how we build it, and the factor of AI. But coming from MathWorks, which is a simulation partner for our automotive community, we are often asking ourselves the question, is model-based design relevant to our engineers, to our customers in this changing landscape? And let me try and answer that question. But before we do that, let's take a quick minute to understand what is model-based design. Model-based design is essentially the systematic use of models throughout your development process. So modeling and simulation helps you to try out new ideas, to perform fast and repeatable tests. It also helps you to automate key steps like code generation, verification, reporting, and so on. And of course, we know with automation, we can reduce the manual steps and also reduce human errors. So with this definition and understanding of model-based design, let's look at how we can help you to handle some of these changes and to mitigate some of the risks. And let's start with the paradigms I had introduced earlier in the presentation about software complexity. Now, essentially, for changing architectures, model-based design allows you to migrate existing components to newer architectures. So you can design, simulate, and deploy your models and code to industry standards like AutoSAR Adaptive, ROS, DDS, etc., without losing legacy work. So this is one big advantage you get using model-based design for this changing paradigm of architectures. Now, model-based design can also help you to achieve hardware and software independence. It helps you to have workflows that are independent of the underlying targets. And when you're ready to generate code, the code generation capabilities can help you to generate to a microcontroller, to an FPGA, or even to a fast compute GPU. Now let's look at how we can help in system integration and early verification. And this is truly where we see a model-based design acting as a multiplier. It can help you to verify and validate software much earlier before you have the hardware or vehicle prototypes. And it also helps you to scale simulations starting from a component to a complete system, and now to the very complex scenarios that we need to simulate, which is the demand of automated driving engineers. So essentially helping you overall to manage your software complexity. Let's quickly take a look at how we can help you when your software development processes are changing. Now, MBD tools integrate with both parts of the DevOps world. It integrates with the tools that engineers use as well as what IT operations uses. So essentially, it gives you an end-to-end workflow through the DevOps cycle. And the results for you are that you have a faster time to production with lesser risks of quality and rework. And before I go to the third paradigm of AI, let's look at how basically the model-based design and the AI solutions can exist. Now, AI solutions give you an AI algorithm, but the story of AI doesn't end with that. There needs to be a workflow around AI. The AI algorithm has to be integrated into a system. It has to be tested, and then it has to be deployed. And this is where we see engineers falling back on the MBD backbone. So MBD essentially gives you the domain context that is very often needed to develop these algorithms. And it can also help you to support deployment of these to a range of targets, starting from an edge device, a cluster, or even to a cloud. And let me take you quickly to 3 of these examples so you're able to appreciate this a little better. Now, in the first half of the slide, you see how two user success stories coming from Ford and Honda, and how essentially they use their data to understand the requirements and the design of their vehicles better. Now, Honda had no experience about DPF calibration for Indian drive cycles, but they had a lot of fleet data by virtue of running their vehicles on Indian roads. And that's when they collaborated with us to understand what can be the best calibration based on this data. Ford, on the other hand, used data from their automated driving fleets, and they wanted to understand how they can improve their design based on the edge cases that they encounter in the data. So that's a little bit about how you can mine requirements from data. In the bucket of developing new capabilities, there's no better example than the perception stack that we are developing for automated driving vehicles. Without deep learning and AI, developing features like this would have been otherwise difficult in the automotive space. So that's a little bit or an example about how we can develop new capabilities. And the next slide, and for those control engineers in the crowd, you will immediately recognize this slide as a controller algorithm and an environment and a plant model with that working in closed loop. And we are seeing several use cases where AI can already be leveraged both to write the algorithm as well as to develop your plant model and your environment. So essentially, AI also has a space running very closely with traditional workflows and with MBD. Very quickly summarize, and Dipanshu, this is my penultimate slide. We talked about how software is going to change the way we build the vehicles for the future. 3 large themes there: complexity, development processes, and AI. And to very quickly leave you with the message that model-based design can help you to manage and mitigate many of these themes, be it modeling for architectures, code generation, helping you to align with CI/CD workflows, and of course, helping you to understand AI better, helping you to deploy that in the right, domain environments, and leveraging that for offering newer capabilities that would otherwise be difficult. And to end, I want to leave you with this slide and ask you this question. That what's the next thing you want to do with model-based design? And we as MathWorks are very keen to be part of your future journey. Dipanshu, that's all I had. Thank you.
Fantastic. Thank you, Rashmi, for that insightful presentation.